Hi, so I was a little bit interrupted. Software is failing. It's just another way of saying we need to support this channel and make some contributions so that I can upgrade my equipment here. Anyway, I just thought let me quickly come back to question 2, the one of the hidden quadratic, where we solved for y, and why I said only this answer will make sense. Of course, you can check your solutions. If you were to check your solutions, say for example, you say 3 times 1 over 9 plus 5 times 1 over 9, and you square that, or you raise that to the power of a half, minus 2, of course you'll get 0, so this answer therefore makes sense. But if you were to do the same thing, and you were to put in the value of 4, so that's 3, and I have got 4 here, plus 5, 4 here, square root, minus 2, well, it will not equal to 0. In fact, that is 12, plus 5 times 2, that is 10, minus 2 will not equal to 0. So you realize that it's a horror show here. So this is like where we're at. This is 22 minus 2, which is basically the same as 20, and obviously 20 is not equal to 0. Hence, only this one works. Okay, let's just fast forward to question 12b. That's where I was interrupted, so I'm going to do that one over again. Question 12b, where are you at? Good, here we go. Question 12b. So, let's write down what we have so far. Again, we know that the water flows into the container at a rate of, so this is dv dt, which is 36 cubic centimeters per second. Okay, and then they are saying we also know the volume of a cone. Okay, from our previous answer that we were supposed to show, obviously it disappeared, but if you follow the video you will see. But I'm talking about this one here, 3 pi h cube over 25. So that was 3 pi h cube over 25. This is dv dh will be 9 pi h square if you differentiate that, okay, over 25. Very important. So what are they asking us? They say we should find the rate of change. So what must we find? We should find the rate of change of h with respect to t. This is what we need to find. Okay, and they will give us when h is equal to 15, and then we must give our answer in terms of pi. So let's first find dh dt. So using the chain rule, dh dt, dh comes over there, dt comes under here. Here you are going to have the same letters, which is dv, dv. Now, one thing that you must also now realize, this is dh dv, but this is dv dh. So to change this one to dh dv, you have to sort of invert this one. So it becomes 25 upon 9 pi h squared. So this is 25 over 9 pi h squared. dv dt, we already know what dv dt is. dv dt is 36 cubic centimeters, so we're just going to have 36 there. Just write 36 over here. So this is going to give us dh dt. Of course, this is nothing but 900 over 9 pi h squared, which is 100 over pi h squared. Right. They say we are supposed to calculate, find the rate of change in terms of pi when h is equal to 15. Therefore, we'll say dh dt when h equals to 15 is equal to 100 over pi times, obviously our h value is given to us as 15. Right, so this is 100 over 225 pi, which you can sort of, simplify, I guess. Let's see, it's 100 over 225, I think, over 225, that's 4 over 9. So this is 4 over 9, and the pi should be under. Okay, this is h, which is like distance, centimeters, over time. Okay, then that is, well, you are not going to be penalized for this particular case if you didn't have the units there. All right, so of course you get 1 mark for correct differentiation, dvdh. You get 1 method mark for correct rate of change using the change rule. You get 1 mark for substitution of the h equals 15 into dh dt, and then the correct answer at 4 over 9 pi. Right. Question 30. A function f of x is defined for x greater than 0 and such that the derivative of that function, or f prime of x, is equal to 4x plus 6 upon x squared. The curve passes through the point p, -2, -1. Find the equation of the curve. We are busy with integration because we have to go back. We have the derivative function. We need to find the function. That means we must integrate y equals to the integral of 4x plus 6 over x squared with respect to x. Okay, well, this can also be written as y equals to 4x plus 6x raised to the power of -2, also with respect to x. Okay, now anyway, if you were to differentiate, to integrate, yeah, you add 1. Okay, so that's going to be 2 here, divide by that is 2x squared, and that's -2, add 1, that's -1, so it's going to be minus 6x raised to the power of -1, plus the constant of integration. Remember that constant of integration, since we don't know what the value of c is. We are actually going to determine the value of c. All right, let me just clean up. This function is going to be y equals to 2x squared. Okay, that x looks, social distancing is all over the place now. 2x squared minus 6 upon x is the same thing, plus c. What do we know? We know that we are given a point. The point is -2, -1. You can just go scroll up a bit, and then you see that is the point over there. Right, so we have that point for x and for y, so now we can substitute that point for x and for y in order for us to find the constant of integration. So it's -1, 2, and everything is -2 for x, minus 6 upon -2 over there, plus c. Of course, this is -1 equals to, well, all of this will give you 11, plus c if you were to multiply, so on and so on and so on. Just use your calculator. Obviously, c will equals to 12. Okay, -1 minus 11, c is equal to -12. All right, therefore, the equation, then you say, therefore, the equation is y equals to 2x squared minus 6 over x minus 12. Anything equivalent to that. 1 mark for integrating, 1 mark for when you are adding the, include the plus c, constant of integration. 1 method mark for correct substitution of the point into the function, and then obviously correct mark for the function itself. Okay, question 14. The diagram shows the curve y equals to the square root of 3x plus 3, meeting the x-axis at A and meeting the y-axis at B. You're supposed to write the coordinates of A and B. So the equation of the y-axis is x equals to 0. The equation of the x-axis is y equals to 0. So if we want to know where this cuts the y-axis, we make x equals to 0. So that means y equals to the staff root 3 times 0 plus 2. Of course, that is just giving you square root of 2. If you want to know this one here, we make y0. So that will be square root of 3x plus 2 is equal to 0. Well, taking the square of 0 is 0. You will get that x will be, if you solve this equation, x will be negative 2 over 3, which is what this value is. All right, so point A is negative 2 over 3, comma 0. And point B is 0, comma square root of 2. Okay, 1 mark, correct answer only. The region is rotated through 360 degrees about the x-axis. Well, once you have that, there's some solid that is being formed over there. Maybe I should I'll show you a second method that we are going to use that, right? Importantly, you need to know the formula for the volume of a revolution, which is v equals to pi, and you have the definite integral of whatever your function is. Say, let's suppose our f of x, which is our y, f of x, this is y, squaring that, okay, with respect to x. So this is y, okay, so f of x is the same as y. So if we take our function, which is y equals to 3x plus 2 under the root, and well, you can go ahead and you can actually already make this a y square. And if that is a y square, because take away the square root by squaring both sides, that is y square equals to 3x plus 2. This is nothing but v equals to, now you have those limits of integration. This f of x is nothing but y square. Can you see that? Maybe I should put the 2 on the outside. Y square dx. So we know what y square is. We can just put that whole 3x plus 2 in here. Okay? Or you can put it under the square root and have the square. The square root and the square will cancel each other anyway. Right. So that's the general formula. So we are going to have v equals pi, and then you have the function. Let's suppose I take what is it? I don't have to use so many brackets. I can just use one particular bracket, and that is 3x plus 2 from negative 2 over 3 to 0, okay, with respect to x. Okay, now we can integrate. You don't have to put plus c when you integrate because the c's will cancel. Anyway, so I'm going to have we're going to have the integral, or when we integrate, we are going to have adding 1 there, that is 3x squared over 2 plus 2x, okay, from that negative 2 over 3 to 0. Okay, from here, obviously, do not forget our pi value. Okay, so yeah, we can go ahead and put the highest one in there, so it's pi, right? So we have yeah, this is going to give me 0. If I put the 0 in here, this is just going to give me 0. If I put 0 here, so this is going to give me 0 for this instance. Minus, if I do the second part, so that's 3 in brackets, I'm going to have minus 2 over 3 all squared upon 2 plus 2, and then minus 2 over 3. Okay, and this is, if you were to do this, you're gonna get an answer of pi times 2 over 3, which definitely is 2 over 3 pi, and the units here, because it's volume, will be cubed. Okay, so you get you don't get a mark if you put a minus there, and obviously you get 1 mark if you give your answer in terms of pi, because it says you must give your answer in terms of pi. You get 1 mark for integration, the methods, and yes, and another mark for realizing this particular fact here. Okay, right. I have another way that I am solving this question, and perhaps just as a matter of interest. So if I was to have my Cartesian coordinate system, um, let's say like so, and the function goes right like so. Let's say this is obviously the x-axis, that is the y-axis. Then you also know that this part here is shaded, and the distance from here, obviously this was negative 2 over 3, so the distance is 2 over 3, and this one was root 2. I just want you to see that if I was to rotate this about the x-axis, as they are saying, find the volume of the shaded region, giving you answers in terms of x, in terms of pi. If you rotate it 360 degrees about the x-axis, so what happens is this actually becomes a cylinder of some sort. Okay, if you had to rotate that whole thing, it's going to become like something like just excuse my drawing. So let me just see if I can have my drawing nicely. It's very difficult to try to draw these 3D things. So yeah, it's like a disc, right? And the x-axis, let's suppose we are going this way, then we're going out, then I go up. Well, it's a little bit, let's just remove that one. Maybe I will move it a little bit. Okay, let's see if we can do this. It is not very easy to do. Yeah, let's suppose you get the idea. If you were to rotate this now, the shaded part is obviously going to be, let's use a different color, perhaps. It's going to be that, it's going to be, it's going to be that part in there. All right, it's going to be that part in there. So when you rotate this, you can see that this is a cylinder where the height, or the radius, sorry, the radius of the cylinder is root 2 because of that particular place. And the height of the cylinder, the height of the cylinder, which is the distance from here to here, this distance here, this could be like the height. So, and that height is 2/3. Okay, it has to be an absolute value. So the height is 2/3. And the volume of a cylinder is pi r square h. If I use this information, okay, because if I change it or I turn it around, it becomes like a disk like that. So the volume would be pi, the radius is √2 squared, and the height is nothing but 2/3. Now if I was to multiply this out, it will give me the volume of the whole cylinder, and it will be pi times 2, because the square root and the square they cancel, times 2/3, and the volume would be 4/3 pi. That is the volume of the cylinder, that solid of revolution. Okay, the solid of revolution being in this case the cylinder, if I was to do it like that. But what do I know? I know that the shaded part represents only half of the cylinder. So in effect, if I have to find the the volume of the shaded region, I'll have to divide that answer by 2. Okay, so volume of shaded region would be whatever the volume of the cylinder divided by 2. This gives me 2/3 pi. Can you see that? Which is units cubed. And lo and behold, this answer over here is exactly the same like the other answer over here when I was doing integration. I thought it's very interesting that you could have also attempted to do it like that. Okay, right. This is Mr. Max with Sankofa Mathematics. So I've been doing these videos for since 2 o'clock. This is the second part. Remember to subscribe to the channel as well as to get hold, make contact with me so that we can see if there are more things that you need. Also, obviously, drop me an email at kashwangamix at yahoo.com. This is also for if you have questions that you would like to ask me. So for any questions, um, you know, things, comments, you know, um, queries, questions, comments, any concerns that you might have. Now, as far as I am concerned, I am doing these videos, um, you know, during the odd hours of the night. I need to upgrade my system in order to reach most of you. I will try to finish paper 2 of last year and then take 2021's paper 1 and paper 2. But all of that takes time. So let's think of making contributions of some sort uh, in order for me to improve my system. You have seen when I was doing part 1, um, I it the system just went off. Okay, so the things I'm using are giving in financial contributions by contacting me on the email so that I can see how we can arrange it. I need to upgrade. I will also make a video to show you the material, my equipment I use from the mics, my whole setup basically, so that maybe some of you also think of doing the same. so that you can have more or less the same type of thing to reach out to the Namibian child. Okay, so support Namibian teachers. Again, I find it extremely difficult to find the time because I have a day job. But if the queries are coming, then whenever I find time, I do it. But suppose the queries are coming, people are contacting me, people are trying to improve, help me improve, subscribe to the channel, drop me an email so I can give you contact details on how we can improve this, and let's talk. And then I can solve anything. Even if you would need a copy of this question paper, I can definitely mail it to you. But it's also available. It's also available on my Google Classroom. Of course, I'm now uploading part one, but if I was to go to my Google Classroom, um, you will see that you just follow and then just follow my lead here. Just bear with me, the internet is a little bit slow, okay, at this hour. For you to be able to also, download material, more material, I have the question papers over here, so you go to Google Classroom. Just wanted to get to that part. You'll see the icon. It's like a little green thing, like with a chalkboard. It's this one over here. Oopsie daisy. This one, Google Classroom. Well, click on it. Of course, you can join my classes. I will put the code up, and then you can write down the code. You can join via the code, or you can join via email. It's totally up to you. And then you can download the question papers and other material that I am posting here. I'm also going to upload grade 8 and 9 work in between, but I want to focus more on the AS level content because I understand the request is high. Um, but remember, in order for me to take time to do this, we have to talk about the things that we can do to help each other. All right. Otherwise, it takes far in between for me to upload this stuff. All right. I just want this to get to the Google Classroom. Um, I am uploading, let's say, 59%. Part one. This is questions 1 to 12b until that little interruption took place. Um, well, it's taking a while to do that. Okay, it's taking a while to get to the Google Classroom for you to join the codes, but I'm going to put in the description below how the code for you to join the AS level class. All right. Okay. Do take care and good luck with your studies. Um, Upcoming examinations in August. I mean, in November. Um, be prepared, work smart, don't work hard. But sometimes, the reverse is true. You need to work hard sometimes to be smart. I don't know. It's all about putting your time management. At this time, you do question papers, you spot question papers, you work with the syllabus. Remember your syllabus, not a textbook. Okay, so let me see if I can get to the AS level classroom. They are still loading. I have it here, grade 12 AS level plus the old higher level. Okay, the internet is very slow because I'm doing quite a lot of things, but the classroom is opening. There are quite a number of classrooms that I have on Google that you can also get in contact with me and share the codes with you, and you can use these in your classes and so on. Right, looks like I'm talking a lot. It's 5 o'clock in the morning, September the 7th. I just want this to open so that I can have the code ready, so that you can download the question paper, and then you can also then, as I work, you can also then sort of follow how to answer the questions and stuff like that. Now, my methods it's not supreme. You might have other ways, means to get to some of the answers. By all means, as long as you work through the content, make sure that everything is fine. Okay. you would not have difficulties, right? Also remember that it took me about 2 hours, an hour and something, to explain these videos and to upload them. You have 2 hours in the examination to write them, okay? And if that's the case, then you should be able to, um, not have a problem. So this is the code that you use to join the AS level classes, SKT3. I think that's an L. N4. Okay, can definitely join with that code, and then you'll have access to a lot of classwork or material that I've uploaded. Just want to see if it pops up. I know it seems like I'm talking forever, but I just want to show you. Once you are on the Google Classroom, you will see that I have numerous activities here that you can download, like for example the question papers of last year for AS level, as well as the question papers of 2021. Okay, so there are quite a lot of material up here that you can download, and then you can work out the question papers. Um, I have some mock exams that I was doing, things on binomial theorem and sequences, binomial theorem. Some of the videos I did. This is paper 1 and paper 2 of 2021. It's here, so you can download it. Okay. You have some test things that I've done. Then I just want to see. Well, you will find the question papers over there. Um, so once you get to it, you can download it. Obviously, then you have the material. Well, it's some loading, and if you need any other material, just get in contact with me. Okay. Good luck with your studies.